Hello everyone. This summer I was fortunate enough to work with the Cascade Head Biosphere Collaborative and investigate climate change monitoring to see if there have been any impacts, recent changes in recent years. My mentors were Duncan Berry, which is the co-director of the reserve, Mary Gus, and Jack Barth, which is here. And I hope you enjoy. Okay, so a little bit of program background. So the Cascade Biosphere Collaboration is a 110-acre site designated on the Oregon coast for its protection and research. It was established in the 1970s, and it has been recognized by the United Nations Marine Biosphere Program. It includes the Salmon River and its estuary, a sandy littoral spit, and has several area designations, some of which is the scientific research area, the experimental forest, the Cascade Head Preserve, the marine reserve, and the marine protected areas. So also a little bit about the Forecast Project. Forecast Project is a research team in a cooperation with other people to inform the public about climate change and to research the environment on the reserve and just inform the public about it. They're called the Forecast as they investigate 4 critical habitats on the reserve, which include the oceanic or the rockline zone, the river estuary zone of the Salmon River, the near shore, and the uplands forest part. And their mission is to incorporate science, art, and research, and just involve everyone to know more about the reserve and what's going on at the Oregon coast. So since the beginning of my internship, the main focus has been to compile data about climate change occurring on the coast and to make predictions about the possible impacts in the future. My main project goals were to answer those 2 questions. Have there been any observable and significant changes in the seasonal air and relative humidity and ocean temperatures in recent years? And is there any correlation of seasonality between them? And can we make any predictions how the rising global temperatures might affect them and the coastal habitats in the future? So my main methods has been to compile and collect data from different resources and to interpret if there have been any climate change in the future. So I was able to gather my air temperature and relative humidity data from the Oregon Department of Transportation's 2 weather stations, one in the former location of the Pixieland Amusement Park and the other one on the Highland Street, and from the U.S. Forest Service's Hubble detectors in the experimental forest in Zone 7 and Zone 8. And I was able to find my seawater temperature from the Oregon Shelf Endurance Mooring, which is operated by the Oregon from the Ocean Observatory Initiative's Coastal Endurance Program. Okay, so those are my results. First, I want to see how the conditions have been going on in the past decade or so. So this is a graph of my relative humidity and air temperature, with the orange bar being the relative humidity since back to 2012 and the air temperature in blue. So overall, we can see that there is some seasonality going on. Especially with the air temperature, we can definitely see the summers and the winters very prominently. I have some missing data from 2021 or 2022, but overall we can see how conditions have been going on in the past decade or so. There is some correlation between the relative humidity and the air temperature. As we can see, usually in summers we have less humidity than in winters, but overall there is a lot of variation between the years, and it's most likely due to different climate impacts, most prominently the El Niño, La Niña events and the Pacific Decadal Oscillation. So we can definitely see that in 2016, 2017, there's a very large drop in humidity. Definitely 2019, though we're not sure if the data is very accurate because it's such a prominent drop than we would have expected. Though we can also see that in 2021, when we experienced the big heat dome, as many of us remember, when just temperatures skyrocketed to 110 across many parts of the state. So we can definitely see that The conditions are relatively stable, and it's very hard to see any change so far, but it's good to have a look at them, just see what is going on over time. We can also see at the ocean temperatures the past decade. So this is data from the OI. It goes back to 2015 up until like current conditions. So we can see that there is definitely a lot more observed seasonality. So it's very hard to see here on the plot, but those parts where the temperature is more constant is generally in winter, while in summer is when we experience those like very big shifts in temperature, which is definitely due to the upwelling here, of course, on the coast, which is when north winds strengthen. So we get the surface waters pushed out further into the ocean, and the deep and colder waters rise to the surface. So we can definitely see when the upwelling events have been occurring, when there's like a very large drop in temperature, and those like very beneficial, very important events here on the coast, as they bring nutrients up to the surface and they support many fisheries and other marine life that lives here. So they're like very associated with like whale migration, increased like fisheries production, and they're very important to the economy and the local environment. So overall, we can see like there's like more stable conditions in the ocean temperature, which is overall expected, as they're less influenced by rapid air temperature changes, since they're like very much influenced by currents going on, and generally water has like a very high specific heat, so it won't experience as much air temperature changes than the land. So overall, we see how the conditions have been, but can we observe any changes like over time? So I decided to do this by so before that, it's good to see how the air temperature and the ocean temperature like vary together. So this is data for the air temperature in orange and the ocean temperature in blue for like 1 year only, for like 2017. So we can definitely see the ocean temperatures are much more stable, except when there's like a large drop in winter. No, winter in summer, when we have the upwelling events, which is like an interesting thing. The ocean temperatures are actually the lowest in summer and the highest in winter, because of those upwelling events, which is like much more, it's just inverse of the air temperature data that we have. So it's they probably act as like regulators of each other. So the air temperature here on the coast is very like, it doesn't like skyrocket as much, just because it is regulated by the ocean temperatures being lower during that time. So we can definitely see some of those upwelling events as the drops in temperature. So it's important to see the seasonality before we can make any predictions about what can happen in the future. So so then I want to see if those variables have changed over time. I decided to find the monthly averages of all those variables for like several years, and I chose to use the monthly average of the month of July, just because in summer is when we see the most variability, and it would be like a good way to investigate how climate change could have impacted those variables in the future. So this is the monthly average relative humidity. This is the air temperature, and this is the ocean temperature. So we can definitely see a very clear decline in the relative humidity over time at the rate of almost 0.92% year after year. There is a consistent rise in the air temperature at a rate of 0.12 degree Celsius per year, and a consistent drop in ocean temperature is interesting at a rate of 0.26 degrees per year. So what can we interpret? What can we think of those results? So for the air temperature increase, this is definitely consistent with what we're seeing with global warming, as the global temperatures have been consistently rising since the 1800s. Although what we're seeing here is the trend is much higher than the observed global average, which is definitely most likely as we're not considering the average increase of the temperature over all the months, but just for the month of July. And it is definitely a thing that we need to consider about the data, and it can possibly point us that there is larger seasonal variability occurring on. So it's possible that the summers are getting hotter, but overall they're balanced out by the winters, as there's probably not that much temperature change during that time, which could explain why we're seeing a much larger trend of increase for July months, but not globally overall. And for the relative humidity decrease, this is definitely consistent with what we're seeing for the whole state of Oregon, as most of Oregon is almost in a multi-year drought, and it's expected that in the future drought conditions will probably be 11 to 33% longer than they would have been. And we're currently experiencing the largest drought in 1,400 years, I believe, which definitely exposes more communities to the risk of wildfires and crop failure, which is definitely a condition that we need to be worried about in the future. And the most interesting, at least for me, is why we're seeing a consistent drop in the ocean temperatures over time, which is counterintuitive to what has been going on globally, as overall we're definitely seeing a global average increase in the ocean temperatures. And actually, Oregon coastal waters have been warming up at an average of 0.0 degrees Celsius per decade. So this can point us to a few things. It is, well, since we're considering like just the month of July, this is definitely a factor to think about. This is the time of upwelling events, so this can possibly tell us that due to global warming, the north winds could possibly be strengthening, which could actually strengthen the upwelling events that happen, which bring even more cold water to the surface, or that they were occurring earlier in the year than they would have been. So this is a good factor to consider, since it can actually probably stabilize the air temperature. So we're seeing even less increase in temperatures than it would have been without that. But it's also like an interesting factor, as we can see that the seasonal variability of the ocean and air is changing over time. So it's like another factor of climate change. So what would be next steps to explore for my project? I want to like recognize some of the work done by Forecast. In the past several years, Forecast has been cooperating with the Forest Service to deploy 40 phenological cameras across the Cascade Head experimental forest, where they take continuous pictures of 4 species of berry-producing plants, which is the salmonberry, saval, huckleberry, and elderberry. And they essentially record when the plants show fruit, when they flower, and different phenological changes. So future steps for this project or a similar project in the future would be to see if any of those phenological changes like are changing or shifting over time. For example, are the plants flowering early in the year than they should be because the temperatures are rising quicker than they would have been? And this way we can investigate, is there like any direct environmental changes that could be attributed to climate change occurring here on the coast? And so as a conclusion, during the course of my internship, I've been able to collect and compile data about climate change occurring on the coast. I investigated 3 variables: the air temperature, the relative humidity, and the ocean temperatures. And overall, I was able to observe an ongoing rising trend in the July air temperatures and an ongoing decreasing trend in the July ocean temperatures and relative humidity. It is important to continue doing this type of work, as continued research and monitoring by other state agencies and federal agencies and people at the Cascade Head Biosphere Reserve can better help us understand how our coast could be impacted by future climate change and understand what kind of effects it can have on the local environment and habitats. Those are the references that I used. And I want to like thank my mentors, Duncan Berry, Mary Gus, and Jack Barth for like helping me succeed with this project, and all those agencies that made the MACO internship possible. So thank you for the attention, and hope